Alright, here we go. This is college, or Scholar Strife. Not in college. I'm done with college. Scholar Strife doing 6.3. This is, what is this? Function composition. Okay, so this should be totally new for some people, but we'll always go back and review stuff that we do know how to do. So here we go. Function operations and compositions. Let f and g be any two functions when you perform operations. F and g, the new function h is obtained. You don't have to call it h, it's just f, g, h is alphabetical order. Anyways, example. Addition. Add two functions together. So we have f of x being 5x and x plus 2 being g of x. So h of x is f of x plus g of x in this case. 5x plus x plus 2. And I'm going to put this in parentheses because if we had a minus sign, that would change what's going on here. But since we have a plus sign, we can drop the parentheses and just add like terms. 6x plus 2 is now our function here, our new function. Okay, subtraction. Here we go. H of x equals 5x minus, and then parentheses x plus 2. Okay, this minus gets applied to both here and here. So this 5x minus x, which is 4x, and then we got minus 2. Multiplication. I'm going to multiply the two functions together. So I have 5x, put that in parentheses, x plus 2. Okay, this is a simple distribution. So this is equal to 5x squared plus 2x. Okay. H of x equals, so now we're doing division. So you just divide the two. It excludes values such that g of x equals 0. Okay, so we have a domain restriction. And we'll show you in that example right here. H of x equals 5x divided by x plus 2. There's nothing we can do. But notice, in our domain, x cannot be equal to negative 2. If I put negative 2 in, we'll get 0 in the denominator. Anything divided by 0 is undefined. It's against the rules. Don't do it. It's wrong. Some people say it breaks the commandment of math. Okay, let's move on. More examples. And he wants to find the domain. Okay. Let f of x be 4x to the half, and g of x equals negative 9x to the half. Okay, so we want to add them first in part A. That seems to be easy enough. 4 apples minus 9 apples. How many apples is that? Negative 5 apples, where apples is x to the 1/2. And then we're going to write this in square root form or radical form. So this is negative 5, and then x is to the 1/2. Not negative 5, x is. So this is the square root. Boom. So remember, 1/2 is the same as square root. Okay, what's our domain? Domain. X has to be bigger than 0 or equal to 0. We do not want a negative. We don't like having a negative number in the radicand because that'll give us imaginary numbers. We just want real numbers that we can work with. Part B, subtraction. Again, this is 4 apples minus 9 apples, which is the same thing as 4 plus 9 apples, which is 13 apples, which is 13 square roots of x. And once again, domain. X is bigger or equal to 0. Next, let f of x equals 6x, and g of x equal x to the 3/4. Okay, doing multiplication. So this is 6x times x to the 3/4. Okay, so that means we add the exponents together. So 6 is by itself, so that's 6 to the 1st. And then x, I would like to think of this as 4 over 4, because that's the same thing as 1. So this is 6 to the 7 over 4. Okay. And that transforms into the 7th root of 6 to the 4th power. Oh, sorry. Sorry. I forgot my x. There we go. Because 6 is not being applied to the 7 to the 7 over 4. X is. So I have 6 outside, and then x is being applied to the 7th root of x to the 4th. There we go. Did I do that backwards? I did do that backwards. That is 6. So remember, top number is the power, bottom number is the root. So this is the 4th root of x to the 7th. Okay. And we can reduce that because we could pull out, there's 4 x's in here, so we can do that. Because remember, this is the same thing as 6 4th root of x to the 4th times x cubed right here. So what's left inside is the 4th root of x cubed. Okay. And the domain, once again, x is greater or equal to 0. Could the domain be something different? Yeah, I could. Especially, maybe, well, especially with the division problems. But this next one is actually going to be the same. But here we go. So f of x is 6x, and we're just going to put 4 over 4 again because we're using fractions. And that'll make it easier on ourselves. And then we're dividing by x to the 3/4. So remember, that's just 4 to the 4 minus 3 to the 4. So we have 6x to the 1/4, which is the same thing as 6 times the 4th root of x. So, domain x greater or equal to 0. And by the way, this is h of x. This is h of x. This is h of x. And that is h of x. Okay. Should I pause the video or should I keep going? Or I feel like I'm going to mess up. Yeah, let's just keep going. You guys get better quality if I don't stop. Here we go. Better video quality, so nothing's blurry. Okay. Here we go. How to find the composition. Okay. So, so f of x is 2x minus 7, and g of x equals x squared plus 4. Okay. This is g of f of 3. Okay. Okay. So how would I write this? What's going on is g compose f. So this circle here represents composition or compose, and it's just saying g of f. That's basically what it's saying. So that's what's going on here. Okay. What it's saying is we're going to do f of 3 first. Okay. So we plug 3 into our equation. So f of 3, plugging x equals 3 into our equation, see what we get. We get 2 times 3 minus 7. This is 6 minus 7. Okay? I'm not going to mess with the left side. That is my function. Okay? So 6 minus 7 is negative 1. So when x is 3 in the f function, y is negative 1. Okay? Now, since we know what that is, I'm going to plug it into g now. So g of negative 1, okay, is equal to negative 1 squared plus 4. So 1 plus 4 is 5. So, to review, g of f of 3 is equal to 5. Alright. So here we go again, part B. This time we have a variable. And this time we're doing f compose g. Okay. So here we go. Fog. So we're going to first do g first. So g of 2y. So every time we see an x, we're going to plug in 2y. So 2y squared plus 4. So that is equal to 4y squared plus 4. Okay? And we can't do anything else. Okay, and then we're going to plug this in to our f function, which is all the way up here into the x power. Okay? So f of g of 2y is equal to, so I have 2, and every time I see an x, I'm going to put 4y squared plus 4. Okay? Minus 7. And that's going to be 8y squared plus 8 minus 7. So that is 8y squared plus 1. Yeah, that's it. Boom, 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 boom. And that is equal to the f of g of 2 of y. Or f of g of 2y. Jeez. Here we go. Next one. Perform each operation, find the domain of each. Here we go. F of g of x. Okay? So I'm just plugging it. So g of x is g of x. I'm not messing with it. I'm not plugging in 1. I'm just just leaving the variable there. So every time I see an x, I just leave the x there. So g of x is 5x minus 2. And now I'm going to plug that into this x value here into my f function. Okay? So, for x, which is now 5x minus 2, to the negative first. So remember, we have a negative exponent. All we do is move it to the other side of our fraction bar and make it positive. So this is actually 4 up top, and then on the bottom, 5x minus 2. Okay, that is our f of g of x. Okay. And then what's the domain? What x cannot be? Okay, so we look at our denominator, set it equal to 0. So 5x minus 2, because we do not want our denominator to be 0. So 5x equals 2. So x equals 2/5. So our domain, x cannot equal 2/5. Every other number works. Okay, g of f of x. So we're taking f of x now. Okay, I'm just going to erase this here. I'm going to take f of x for part B, and then plug it into here. So 5 times 4x to the -1, and then minus 2. So 5 times 4 is 20. And then we have minus... Oh... Wait a minute. Sorry. Yeah, height of 4 is 20. And then x goes on the bottom. And then we have minus 2 over here. Right? Okay. So that is our function, g of f of x. So our domain, x cannot equal 0. F of x. Well, this is just silly. Basically, we're plugging the function into itself. So, it's kind of weird. So we started off with 4x to the first, or negative first. So every time I see an x, I'm going to plug in 4x to the negative first. So this is 4 times 4x to the negative first to the negative first. Okay? A little confusing there. Now I'm going to apply my exponent. So I have on top, I'll write it out. And so this is 4 times 4 to the negative first, x to the positive first, because that's multiplication there. So now, since these are all being multiplied, create my little fraction bar. So 4 goes on top, this 4 goes on bottom, and this x stays on top. So we're just left with x. And the domain for this one okay, the domain for this one, x still cannot equal 0. Why? Why? I don't see any x's in the denominator. But all the way, it doesn't matter if your end step, if any of the steps show an x in the denominator, then you're not allowed to have it there. And where does it show it? It's actually in this first step here. X to the negative 1. If I rewrite this, that's the same thing as 4 x to the first. And that's the negative 1. Okay? Can't have 0 there. Okay, next. F of g of x plus 1. Why are you making it so hard? Okay. So g of x plus 1. So every time I see an x in the g of x function, I'm going to put x plus 1. So 5 times the quantity x plus 1 minus 2. So this is 5x plus 5 minus 2. So 5x plus 3. Okay. So that's g of x plus 1. Now, I'm going to do f of g of x plus 1. So let me look at that function again. So I have 4 times the quantity, 5x plus 3, and that is to the negative first. So I'm going to have 4 over 5x plus 3. And that's going to be our function. And then our domain is equal to our x cannot equal negative 3/5. Okay, I just set it equal to 0, move the 3 over, so it's negative 3 divided by 5. Okay, all right, almost done. Word problem. Always the word problems. Percentages and purchases. You have a $10 gift card to a paint store. The store is offering 15% off your entire purchase of paints and painting supplies. You decide to purchase a $30 can of paint and $25 worth of paint supplies. Find the sale price when the $10 gift certificate is applied before the 15% discount. Okay. Okay, this is Okay. Let's say X represents the regular price. Let's say f of X is the price after the $10 discount. Whatever. After $10 discount. Okay. So that's like X minus 10. Okay. And then let G of X be the price after the 15% off. So that represents the total price minus 15% of it, which is 0.85x, right? If you take 15% off, that means it's 85% of the total. Okay. So the sale price, what are we doing first? Decide. So our total price is $55. That was from the $30 can of paint and $25 worth of paint. We want to find the sale price when the $10 gift certificate is applied before the 15% discount. Okay. So we're going to take the 15%. Wait. Yeah, okay. So we're doing G of f of x. That's what we're doing. And what that means, that is the price of the $10 gift certificate being applied before the 15% discount. Okay? So we have x minus 10. So G of x minus 10 is equal to 0.85 x minus 10. And now we know what the total price is, which is 55. So 0.85 times 55 minus 10, which is 0.85 or 45 bucks. Which is $38.25. Okay. Now, I know I didn't do this one, but this is the answer to number 1. Okay. Number 2. Find the sale price when 15% discount is taken off before your $10 gift card. So this is doing f of g of x. Okay. So this is f of 0.085x. So 0.85x minus 10. So we're taking the 15% off first. Minus 10. So 46.75 minus 10 is 36.75. So which one's better? Which is the third question here. Which is the better buy? That would be our second option. So you want to take 15% off, then use your $10 gift card. Take 15% off, then use gift card. Now most stores, they do it this way, the second option. I don't actually know. I've seen stores do this both ways. They apply the certificate and then they take the 15% discount. Sometimes they do it the other way. So be careful with that when you have multiple discounts in place. You got like a certificate, you got military, you got maybe your senior discount, whatever discount, family friendly, I don't know, whatever discounts you have. You can do the math, find out which one's cheaper. Of course, we're not going to write it out like this, but this is what we kind of do in our head, right? If we take, we find our total price 55, take 15% of it, then we subtract 10. Or in option 1, we take 55, subtracted by 10, and then we take 85% of that. So that's what we kind of do in our head with a calculator. But this is the algebraic way. All right, done. One go.